Everyone. This is question number 5 of ESE 2024 CE. If VD is the design speed, TPR is the perception reaction time, A is the deceleration rate, G is the grade of the road, find the expression of stopping side distance. We know that stopping side distance is the minimum distance that a car will travel after it sees any obstacle in its path. So it includes the thinking distance, that is when the driver is thinking that after seeing the obstacle he will think and then he will apply the brake, and then the deceleration distance, that is after the applying the brake. So this is the time. In this thinking time, the four process that goes on in our brain are perception, intellection, emotion and volition. It is recommended to take 2.5 seconds by IRC for SSD. So we know distance equal to speed into time. So design speed into time to think, TR, or time to react, whatever you say, and plus S. S is the decelerating distance. So how we derive S, we'll see now. From class 11 physics, we have seen that equation of motions. V square minus U square equals 2AS. It's a very common equation. And A is acceleration. It can be replaced by minus A when it is deceleration. So if A is decelerating, we get V square minus U square equal to minus 2AS. Now, after applying the brake, the car will come to a final stop. The final velocity will be 0. So we get minus U square equals to minus 2AS, which gives U square equal to 2AS. Again, which gives S equals to U square by 2A. Now, initial speed is the design speed. So that U equals to VD. So S will become VD square by 2A. So we will replace it in the SSD equation. So the SSD equation will become VD into TR plus VD square by 2A. Clear? So now we have two cases. Case number 1, when a car is moving down a slope road, and case number 2, when the car is moving up the slope road. So here you can see, for example, this velocity is going downwards and mg sin theta, the component of weight along the road, acts along the acceleration. Like if suppose v is this way, so this way we'll have ma, so it acts in the same direction and the friction acts in the opposite direction. So this plus this equals to this. Here the car is moving in this upwards direction, so ma will be this way, right? So ma minus mg sin theta, or ma equals to mg sin theta plus f, right? So we'll write the equations. Ma plus mg sin theta equal to mu n. We know friction force equals to mu n, where mu is the coefficient of friction of the surface, n is the normal reaction, okay? And here we write ma equals to mg sin theta plus mu n, right? This is pretty easy. So n equals to mg cos theta. We have already seen in the free body diagrams of engineering mechanics. These things we have solved here. So we get, from the first equation we get, cancelling out m, we get a plus g sin theta equals to mu g cos theta. That gives us a equals to mu g cos theta minus g sin theta. Taking in common g cos theta, we get mu minus sin theta by cos theta, that is tan theta. Again here also same thing, a equals to g sin theta plus mu g cos theta. A equals to g cos theta into sin theta by cos theta plus mu, that is tan theta plus mu. So what we get from here is, first we'll take tan theta equals to g. See here tan theta equals to g. How? Because we have been given that g is the longitudinal grade, okay? So that's why we are taking tan theta equals to g. And assuming this theta to be very small, we get cos theta equals to 1, because as we approach 0, the value of cos theta becomes 1. So we get a equals to g into mu minus g for the case 1, a equals to small g into mu plus capital G. So in generalized form we can write a equals to g into mu plus minus g. So we replace this in the SSD equation. So this can be our form for SSD, but we have to check with the options given. Let's do that. So the options given are in this form, like some VDT with some coefficient, VD square by A plus minus G with some coefficient. So we have almost got the terms. The form of our equation and these options are same, but the coefficients we didn't get. So what we know is SSD is generally reported in terms of meters or feet. Okay, so here as we have feet per second square as the deceleration rate, we have to get SSD in feet. Now if VD is in kilometers per hour and we need to convert it into meters per second, so 1 kilometer is 1000 meters, done. 1 hour is 3600 seconds, so we get 0.278 meters per seconds, right? Okay, so this is the factor that we have to keep in mind while doing this kind of problems in transportation engineering. This value you will come across several times in while doing this kind of equations. So now we get SSD as 0.278 VDTR and 0.278 VD whole square by 2G into mu plus minus G. Again, what we have is miles per hour. Design speed is in the form of miles per hour. Now 1 mile is equals to 1.61 kilometers. So what will happen? This one is kilometers per hour. This one is converting it into the meter per second. So to convert miles per hour to meters per second, we need to multiply 1.61 with this. Okay, so we'll multiply 1.61 into 0.278. Let's see how much we get. Please check it how much it's coming. 0.447 आ रहा है सबके लिए, सब लोग चेक करो एक बार. 0.447. Okay, so we'll replace this equation SSD with 0.447. Let's see how we do that. See, we have done 0.447, we have replaced it. Now we have the deceleration rate in terms of feet per second square, right? So what we know is 1 feet is equals to 304.8 mm. This is a standard equation. In general life, in general practice, we just take it as thumb rule that 1 feet equals to 300 mm, but to be precise it's 304.8 mm. So 1 meters equals to 1000 mm will have 304.8 will divided by it 3.28 feet. Okay, so you can calculate it once. 1000 by 304.8, 3.28 आ रहा है, ठीक है सबके लिए. Now this SSD equation is in meters. We have to convert into feet. So we multiply this meters per second part with 3.28 and this meter per second part within the square we have to multiply with 3.28. So multiply 3.28 into 0.447. See how much you get. 0.28 into 0.447. 1.466, right? You get 1.466. So this value 1.468, 1.468 are almost close to our value. So we can keep it as this only. So the first term we got it. That is this term, the first term is 1.466 VDTR. So we got the first term. Now let's look at the second term. So it will become 1.466 का square, है ना? तो 1.466 का square कर दो, 2.15 आएगा, ठीक है? इसको 2.15 लिख के रख दो, ठीक है? और नीचे ये 32.2 कहाँ से आ गया, है ना? कहाँ से 32.2 आ गया? तो हम क्या जानते हैं, G इक्वल्स टू 9.81 मीटर्स पर सेकेंड स्क्वायर जानते हैं. अब 9.81 मीटर्स को हम फीट में कन्वर्ट करेंगे बाय मल्टीप्लाइंग इन 3.28. How much is the answer? Just see. 32.17. That is almost 32.2, right? So it's clear how 32.2 is coming, feet per second square. So 32.2 we got it, right? That is, we replace this g here. This g has been replaced by 32.2. Okay. Now for a flat terrain we know that a equals to mu g. Okay, so mu can be replaced by mu equals to a by g. That is a by g. Again we know that g equal to 32.2. So we can write a by 32.2 in this place, right? So the equation will become, SSD will become 1.466 VD into TR plus VD square, that is 2.515 is there, 32.2 is there, and 2 is there. Okay, so let me take a different color. Which color? Okay, we'll take violet. So 2.15 divided by 2 into 32.2. So you do it, 2 into 32.2 by 2.15. 2 into 32.2 divided by 2.15. You get 29.95, which is almost equals to 30. So this 30 is okay, right? A by 32.2 plus minus g. So we get this kind of a form. So let's see which option is correct. See, this option is not correct. D is not correct. This option is C. B is not correct. Option C is 30 is there, 32.2 is there, but there is a minus. So it's a positive. So it will be A option. Correct, right? So that is the option A. So in this way, if you know the basics correctly, you will be easily able to solve these questions, because this kind of question will come in ESE, GATE, anywhere it will come, and in GATE they will ask you to solve a problem. And so if you memorize this kind of formulas, you might get confused with the, like, which one is plus, which one is minus. Suppose it's ascending, what should I take? It's descending, what should I take? So it's better to know from the basics, right? Thank you.